In this video, we will try to learn how to draw a line structure of a molecule from Newman's structure. Newman structure, a Newman projection structure. And also we wanted to mention what carbon-carbon Newman structure is depicted in that structure. Let us see for example, one molecule with the Newman structure as shown here. We have here CS3 group, hydrogen, bromine, for example, and other carbon is this one here, BrCS3 and hydrogen. So this is the Newman structure of a molecule. We wanted to draw the line structure of this compound, and also we wanted to mention which carbon-carbon bond is depicted in the molecule. Now, to draw the line structure from Newman projection, we know that this is the front carbon that is represented by a point here. So the front carbon is the carbon that we can put here. This carbon here, the front carbon has three groups. One is bromine and hydrogen that are in the point down, and here CS3 group is on the up. So this down group, we can represent this CS3. This is the group, that's CS3, and we have one group is say Br, and here the hydrogen. Now the other carbon, the back carbon, is represented by circle. We can draw the bond for the back, and this is the back carbon. Now we have three group here again, bromine, CS3 and hydrogen. So CS3 is here pointing down, so we can represent CS3 as the down group here, and one we have the hydrogen in the front position and other bromine is on the back position. This is what is the line structure for this Newman projection. Now here the structure is depicted for this carbon number 2 and carbon number 3. So this is carbon number 2 and this C3, that is where this structure is depicting. In other words, this is the same structure that we can draw the line angle formula like here, this one here, this is CS3 and CS3 group, and you have here bromine and hydrogen and other hydrogen and bromine. So this is the line angle, is a CS3 group. Line angle structure for this molecule. That is how we can translate the Newman projection into the line angle structure. Now the other one important discussion that would I also like to do here is how to predict which of the structure is more stable, to find out the most stable Newman structure. Now to discuss this, let us pick the one example here. Say for example, we have the Newman projection for two molecules. Like say you have here CS3 and here is hydrogen and here is CS3, and this is the outer carbon. You have a CS3 group, here is hydrogen and here is other hydrogen. The other structure that we would like to compare with is you have CS3, we have CS3 and hydrogen. Now behind carbon here is CS3, we have hydrogen and here is hydrogen. Now we would like to compare these two structures and decide which structure is more stable. Now both of these structures are are in staggered, but the structure number A here has this is CS3 group on n-type position, whereas these two CS3 group are in Gauss. So these two CS3 group are Gauss have some steric hindrance, but however these two CS3 group are in n-type position, that is in favorable situation. Whereas in structure number B, as we can see, the CS3, these two group are also in Gauss orientation. They have some steric hindrance. Likewise, these two CS3 group are also, they are also Gauss. This is also Gauss. This is also Gauss. There are two, or we can say three CS3 group are showing some Gauss interaction. These two CS3 group and these two CS3 group are showing Gauss interaction. That makes the structure number B less stable compared to structure number A, in which these two CS3 group are Gauss, but the CS3 and CS3 they are in n-type position. N-type is favorable. So A structure A is more stable compared to structure B. This is the result for this one, or we can say this one is more stable compared to B. That is how we can predict which structure is more stable in two Newman's projection. Okay, thank you.